Matrix properties and operations. We're going to look at one tool, matrices, that we can use to solve systems of equations, but first we've got to learn how to work with these items. So a matrix is just an arrangement of numbers, like this right here is an example of a matrix. So it is defined by its dimensions, which are given by row by column. This has 2 rows and 1, 2, 3 columns, so it is a 2 by 3 matrix. A square matrix has the same number of rows as columns. We have 1, 2, 3 rows and 1, 2 columns, so it's a 3 by 2 matrix. We have 1, 2, 3, 4 rows and 1 column, so it's a 4 by 1 matrix. This is 1 column and 5 rows, so it's a 1 by 5 matrix. All right, so 2 matrices are equal if each element in each corresponding place is equal. So like the 0 equals the 0, the -1 equals the -1, the 4 equals the 4. So that allows me to figure out the values of these other variables. 5 has to equal w plus 3. So that means my w must be a 2. Subtract 3 from both sides. 3 is equal to 3, 1 is equal to 1. X must be equal to 6. Y plus 2 must be equal to 0. So that means y equals equal to a -2, subtract 2 from both sides. And z must be 8. To add 2 matrices together, we add the corresponding elements. Notice this is only going to work if they have the same number of rows and columns. The matrices have to be the same size for me to add them together. The 0 matrix is a matrix that has a 0 in every single entry. So for example, here, this is the 1 by 3 0 matrix because there's 1 row, 3 columns, everything's a 0. This would be a 2 by 3 0 matrix. Now, if I, excuse me, if I add together a and the negative of a, -5 added to 5 is going to give me a 0. 2 added to -2 is going to give me a 0. So a plus -a results in the 0 matrix. That is the definition of the additive inverse. All right, so if 2 matrices have the same dimensions, just like we add them by adding corresponding elements, I can subtract them by subtracting corresponding elements. All right, I want to find the sum here. So I'm adding these 2 matrices together. I would go 9 plus -3 equals a +6. That goes in the space where those 2 belong. -8 plus -4 is a -12, so that goes in here. 4 plus 2 is a 6, so that goes there. 2 plus 7 is a 7. How did I do that? 2 plus 7 is a 9. Let's try that again. And so that goes in that entry space. So there's the resultant matrix here. Okay, now let's see how we would do that on our calculator. So I would go over to see the key here that says matrix. We're going to hit second and the inverse key to get to the matrices. I want to edit matrix A. I want it to be a 2 by 2 matrix because I have 2 rows and 2 columns. Excuse me, 2 rows and 2 columns in each of those. Oh, whoops, 2 by 2. 2 by 2. Okay, so I'm going to enter 9, 4. Make sure you use the negative sign, 8, and not the minus sign, and then a 2. And then let's go back into matrix, and we're going to edit matrix B to also be a 2 by 2. And I'm going to put -3, 2, -4, 7. Now if I quit out of there, we're going to go back to the home screen, and then I'm going to pick up the matrix. I just want the names this time, so I'm going to choose option 1 plus second matrix option 2, and there's the result, 6, 6, -12, 9, just like we found by hand. Okay, so now if I, sorry, I should have turned off my mail before I started recording. Okay, so if I add together the elements here, 0 minus 8 would be a negative 8. 0 minus 1 would be a negative 1. 0 minus 9 would be a negative 9. And 0 minus 4 would be a negative 4. Notice that what this did is it multiplied every element by a negative 1. So I'm just looking at adding the opposite, adding that additive inverse in there. All right, let's find the difference of these two. Now, if I go, okay, well, I can say negative 2 minus 3, fine, but then what am I going to subtract with 5? There's nothing in the second place over here. These two matrices do not have the same dimensions. If they don't have the same dimensions, I can't add or subtract them. Now, if a matrix is added to itself, each element is twice as large as the corresponding element of the original. Here, 2, 1, 4, 5 through 6 is added to 2, 1, 4, 5 through 6. 2 plus 2 is 4, and that's twice the original element. 5 plus 5 is 10, and that's twice the original element. So we can multiply a scalar. A scalar is just a number as opposed to a matrix value, right? A scalar is just a number. We can multiply a matrix by a scalar by multiplying every single element by that scalar. So 2 times 1 will result in 2. 2 times 3 will result in 6. Okay, so that's what this is saying. Multiply every single element by that scalar. So here, if I have negative 3 times this, I go negative 3 times 2 is a negative 6. Negative 3 times 1. Negative 3 times 6. And negative 3 times 4. Okay, so again, let's go over here and we're going to go into the matrix. And I am going to edit that first matrix here. It's still a 2 by 2, but I'm going to plug in 2, 1, 6, 4. Quit out of there. And then I want to multiply negative 3 times and go into second matrix, which is, we edited A. And there's the resultant that we got by hand. Okay, so now suppose that you're the manager of an electronics store. One day you receive the following products from 2 distributors. From Wholesale Enterprises, 2 cell phones, 7 DVDs, and 5 video games. And from another distributor, 4 cell phones, 6 DVDs, and 9 video games. So I can make a table like this, which notice this corresponds to the matrix 2, 7, 5, 4, 6, 9, like that. Now, if each cell phone costs $12, the DVD costs $18, and the video game costs $9, then to get the total cost, I'd multiply the number of items times the cost per item, like so. So 2 times 120 equals 240. So, like we would go there, okay? So, the products from Wholesale Enterprises would cost a total of $411. You know, I hadn't noticed this before, but I have no idea why this says the cell phone's 120 and this says the cell phone's 12. I think they meant for this to be a 120 up there, because otherwise that wouldn't make any sense. Okay. So the result of these products is 2 times 1, like that. Okay. Now, we can do this multiplication with matrices. Take our original matrix, which was the distributing of the products, 2, 7, 5, 4, 6, 9. Multiplied by the cost matrix. So if I multiply 2 times 120, 7 times 18, and 5 times 9, I get what goes in the top row. And then if I multiply 4 times 120, 6 times 18, 9 times 9, I can get the total in the bottom row. This is the way we do matrix multiplication. We multiply the first row of the first matrix by the first column and put it in the first entry in the matrix. Then the first row by the second column in the second entry, like that, all the way across until we've done all the columns in the second matrix. Then proceed to the next row and repeat. Okay, so the way that this is written, the product of an m by n matrix A and an n by k matrix B will end up being m by k, however many rows we have in A by however many columns we have in B. To find the ith row, jth column of the multiplication, multiply each element in the ith row of A by the corresponding element in the jth row of B. This is going to make more sense as I walk you through an example here, okay? All right, so here, suppose the matrix A has dimensions 2 by 2, while matrix B has dimensions 2 by 4. Can the product AB be calculated? Yes, I can go with a 2 by 4 product as the result. So yes, those inner two dimensions, as long as these match, I can multiply. So if I have A as a 2 by 4 matrix and B as a 2 by 2 matrix, I can't, because I can't take the 4 columns and multiply times elements over here. There won't be enough. So when these are different, I can't multiply them. Okay, let's look at an example here. I want to multiply AB and BA. So to do A times B, by the way, A is 1, 2, 3 by 1, 2, 3. So this is a 3 by 3 matrix. This is 1, 2, 3 by 1, 2. These match, so I can multiply A times B. So let's do the first row times the first column. So we're going to go 2 times 1. I'll write it here. 2 times 1 plus 1 times 2 plus negative 1 times 3. And that goes in that result goes in the first entry here. Now the second entry is by taking this same thing and times the second column. So 2 times 0. 1 times negative, this 1 times negative 1. And this negative 1 times 1. And then now we're done with the first column, so now or the first row, so now we move to the second row. Second row times first column, 0 times 1 plus 2 times 2 plus 1 times 3. Then 0 times 0 plus 2 times negative 1 plus 1 times positive 1. 3 times 1 plus 2 times 2 plus negative 1 times 3. And then 3 times 0 plus 2 times negative 1 plus negative 1 times positive 1. Okay, so if we work this out, 2 plus 2 is 4, minus 3 is 1. 0 minus 1 minus 1 is a negative 2. 0, 4, and 3 is 7. 0, negative 2, and 1 is a negative 1. And then 3 plus 4 is 7, minus 3 would be 4. 0, negative 2, minus 1 would be negative 3. So our result is this matrix. Now, can I multiply B times A? Notice these are the dimensions of B, 3 by 2, times A, 3 times 3. These don't match, so nope, I cannot multiply those. All right, let's see how to do this on the calculator. So I'm going to go over here to the matrix, and I'm going to alter matrix A, edit, to be 3 by 3. And the entries there are 2, 1, negative 1, 0, 2, 1, 3, 2, negative 1. And quit out of there. Then second matrix, edit, 2, and its dimensions are 3 by 2. And it goes 1, 1, 0, 2, negative 1, 3, positive 1. Quit out of there. And then if I go back into the matrix menu, pick up matrix A times matrix B, it'll give me what we just calculated by hand, 1, negative 2, 7, negative 1, 4, negative 3. If I try to do the opposite, if I go matrix B times matrix A, notice that it's going to give me an error, dimension mismatch. I can't multiply.